Hello everyone, welcome to this webinar, which is storage as a differentiator for cloud, MSP and hosting companies. Thank you for being here. Here is the agenda that we have, and we're going to cover some of the typical storage issues service providers face. Then we're going to go through several ways that you can solve, or better yet, avoid these issues. Then we're going to showcase how StorPool can help you, and we do a brief demo. And then we have our customers and friends from CloudSigma who are going to say several words about their experience with battling with storage issues and how they solve them. And we're closing with a Q&A. So, storage issues. Instead of us explaining what are the storage issues, you know most of them already, but we decided to put some quotes from companies we're talking to who are doing a lot of interesting things and have storage-related issues. And first is quote from a hosting company in Netherlands, and they say the usual problem that storage companies have, which is performance. Another thing that we commonly see is companies that are using local storage, and as the storage farms grow, they are experiencing management and flexibility problems. Also, we see this a lot with service providers that they're struggling to find a proper storage solution for their cloud products. It's becoming an obstacle to running their business and growing it, and it causes a lot of troubleshooting during the night. Lastly, storage is a very big area, and a lot of the service providers realize that the way to build a better company is to focus on their core expertise and not do storage, because it takes a lot of time and effort. So here is an example of how storage performance affects your business. And here is a graph from a customer that was reporting complaints from their customers who said our service is really slow. So this is transactions that are happening over the web, and we stepped in to do some performance improvements on the storage side. And after 2 rounds of performance improvements, you can see them on June 10, when you have a sharp delay, sharp decrease of the storage latency, or the latency. And then on June 13, we had about 10-fold improvement of the performance measured in latency. And this resulted in a customer that was happy. Here is the same thing, but on the bottom, we also put the database queries directly to the storage system to show that any delay that you have in the storage system directly correlates or translates into delay in the overall service that the service provider was providing. And you can see that the 10-fold decrease in latency the web app experienced on the top, from 900 milliseconds to about 100 at the peak. It's almost the same identical decrease in latency that was experienced in the storage system, from about 220 milliseconds to about 25 milliseconds when the optimization was delivered. Another thing that's really common for service providers is the fight for reducing or eliminating downtime. And this is very hard to do if you're not running a shared storage system, because anytime you have a bunch of servers with direct attached storage, whenever something happens to the storage node or to the compute node, you're also losing the storage that's attached to it. So it's you need a proper storage solution. Another thing is you need a solution that allows for upgrades of the software, not only the storage, that are live on a rolling basis or otherwise, but they should be while the service is up and running. Hardware refresh shouldn't cause downtime either, and you should be looking for a storage solution, and there are a number of these on the market that allow to change all the hardware that's running your service without causing downtime. And to do this, you obviously need a working live migration of virtual machines for hardware maintenance and hardware refresh. Improving scalability is one of the top 3 things that service providers are battling with. And now scale out is becoming a norm in the industry. And if you're not running a scaled out architecture, you're falling behind. This should eliminate single points of failure, and this is also becoming a norm. So you should not rely on master slave or some technology like that. Live expansion or shrinking of volumes, live migration, high availability. This is flexibility and management that we touched on a bit earlier, but this is what gives you this functionality. So the flexibility of the storage system gives you a lot better customer experience at the top. Snapshots and clones and QoS per customer are becoming increasingly used as a best practice in the industry. And then you have the price or price performance of the storage system that's running your business. So if you're running on a SAN, it doesn't work commercially anymore. So your cost of service is becoming so high that you're losing your competitive edge on the market. Also, another thing that's becoming really common for a service provider or a best practice is a new storage system. Whatever new solution you're getting, it should do at least 100,000 IOs. This is the new standard, and less than 1 millisecond of latency. But if your storage system is capable of less than that, then your customers are likely looking for a better solution that's providing a faster service. What we see is hosting and MSP and cloud companies are looking for an all-flash solution, but they cannot cope with the high price of all-flash storage arrays, so they're looking for an alternative. One of the other points that they have is they want to stay competitive, and they want to still have their business after giants like Google and Amazon are innovating at a fast pace. And we've done infrastructure architecture that we actually implemented in a number of cloud providers, and it gives you really reduction in your total cost of running a cloud business or a hosting business, and really an outstanding ROI of more than 260%. And you can find it at the link quoted here. And it includes everything from what type of server you should buy, what networking, how much RAM, how to place them in the rack. It's a very thorough design of how to build the most efficient cloud possible. And it's not just storage. You have to calculate power consumption requirements in your data center, and there are a lot of things to consider. So it's a deep dive. Finally, the takeaway is you cannot continue to run on SANs and all-flash arrays. If you want to optimize your whole stack and be competitive, but also have an outstanding service, you should look for software-defined storage technologies. And here are some tips from the practice that we've seen when things go wrong or how to avoid it. So what to do? I think it's a common sense, but you should use tested and widely used firmware versions and latest BIOS. And we see some components are more prone to errors than others. For example, SSDs are you should be very picky about the firmware you're using with SSDs. Then another thing that's counterintuitive is if you want to do a better unit economics and increase the return on your investment in your hardware, then you should pick more expensive stuff. That's more expensive CPUs, more RAM, which basically provide a lower cost of running a VM for your customers. Recent generation of servers, in many cases, we see people trying to reuse old equipment and build a new service with them, which usually is not a good practice. You can do it, but then the servers are consuming too much power or not powerful enough. And instead of doing a new service that has outstanding return and capabilities, you're kind of reducing the investment, but also shooting yourself in the foot with lower performance. Use larger SSDs. Again, using 2 terabyte SSDs or 4 terabyte SSDs over 1 terabyte SSDs is better for the return on your service, as you can use less servers. They're denser, also faster in many cases. Use redundant switches. This is a very important practical aspect, as the network is becoming the backbone of your entire service, and you rely more and more on it. You should make sure that you eliminate the single point of failure, which is usually hiding in the network. So one of the other important points when you pick up a new storage system is to look for a system that's integrated with your cloud management, be it ONAP or OpenStack, CloudStack, OpenNebula, whatever you're using, or even a custom system. You should look for a storage system that's already integrated with this system. And it can do intelligent stuff like quality of service for each individual VM. It can do a separate volume for each VM. It can create VMs from the cloud management. It can save space because it understands the snapshots and clones and templates. So it has a number of advantages. Another simple yet practical point that we see most companies are not doing is to always stress test the hardware before using it in production. Even brand new hardware has problems with it in 80% of the cases. When we deploy a new production cluster, we experience some problems with something. You have faulty RAM modules, you have some network connectivity, cables that don't work. There is always something that comes up, as I said, in the 80% of the cases. And then again, inspect your network, as it's a usual cause for storage problems. It's not just the storage, but settings on the network, and keep an eye on our blog. We're going to post a particular article on how to troubleshoot storage-related problems that are coming from the network. But that's an important point here. Here are some don'ts. And I guess the number one is don't run on 1 gigabit Ethernet anymore. A lot of the service providers say that they don't have the money, but honestly, if you're still running on 1 gigabit, that hinders your capabilities, and the service you deliver is not up to date with the current demands of the customers. And a lot of people think this is an expensive option, but here is like a good product from a company we work with, and we like the products because they have very good price quality ratio, and a 1040 56 gigabit Ethernet switch costs less than 6K. And honestly, even a second-hand 10 gigabit switch, which is kind of like a couple $1,000, is better than continue running on 1 gigabit Ethernet. So you have no excuse there. Another big point is we see many companies are trying to deliver all-flash clouds, but they go and buy a cheaper consumer-grade or laptop-grade SSDs. And the issue with these SSDs are mainly two. One is they have reduced cycles for reduced endurance. And in order to guarantee this endurance, many producers throttle their SSDs, which means they limit the performance that you can get from these SSDs. And the second problem is they are not power loss protected. So you are running the risk of losing data on these SSDs. And given enough time, you will lose data on consumer grade SSDs if you use them for production workloads in a cloud environment. Another thing that we see and we recommend is not to use fiber channel. If you want to build an infrastructure that's future-proof, you don't need a legacy system like fiber channel sitting in your data center anymore. You don't need this rack of hypervisors or compute nodes, and then a rack of storage-only devices or SAN arrays. You know, the compute servers can do pretty well for also running storage software. Another thing is InfiniBand is a good network, and 10 and 40 gigabit Ethernet with ROC support, which is InfiniBand, which is RDMA support, is really fast now and is not expensive, so it's a very good option. Of course, as any solution, don't expect magic. Any technology can fail, so you should plan around that. You should have backups. You should test your HA capabilities, and this is a point that's rather simple. Yet we see maybe half of the service providers we talk to are not running backups, which is really strange to us, to say the least. But it's something that, you know, if you're not doing something on this end, you should. Here are some words about StorPool and how StorPool can help. So what is StorPool? StorPool is software-only storage solution that's running on standard servers. It eliminates the need of a SAN or all-flash array by running on the compute nodes or on the hypervisors, although it can run on a separate tier of standard x86 servers, or it can run in a mixed environment. So hyper-converged or segregated or standalone storage, it can mix. It's fully distributed, so no single points of failure. It scales out and grows. You can just add one additional server to increase the capacity and the performance of your existing storage pool. And this will be done live without downtime, without any disruption to the service. You can also change your entire hardware equipment node by node without causing downtime. StorPool is one of the leading implementations, maybe the leading implementation of distributed storage architecture on the block level. And the results are extreme performance in terms of IOPS and megabytes per second. This is performance, but also efficiency, meaning it takes really minimal amount of resources on the nodes. For example, it can do 100,000 IOs per node with taking just 2 or 3 CPU cores, and it can deliver 200 microseconds latency. It's flexible. I mentioned this before. It can run on the compute nodes or on a separate tier of nodes. And it's running in production for more than 3 years now with customers across the globe and 12 major releases. Lastly, it's integrated with almost any technology in the hosting and MSP world, including ONAP, OpenNebula, OpenStack, CloudStack, LXC. We've run Docker on StorPool, LVM, everything you can imagine. And now I'll hand over to my colleague Bojan Krosnov, who is the Chief of Product at StorPool, who will do a brief demo.
Hello, everyone. My name is Bojan Krosnov, and I'm the Chief of Product at StorPool. And I'm going to show you briefly, what StorPool is about, how it's used. And let's see if our screen sharing thing works. Okay, I think it works. Right, so StorPool, like one of the key aspects of StorPool is deep integration with all popular cloud management systems on the market. Let's try this again. Okay.
This should be it.
Let's just check. Do you see my screen? No? Yeah, weird. Okay, cool. So screen sharing works finally. So the kind of very few storage systems pay attention to this aspect of building a proper cloud infrastructure, is that the storage system needs to connect to your cloud management system, and it needs to react to all kinds of, say, service requests or provisioning requests from your cloud management system and be in sync with it. In StorPool, this is a very important aspect of our product, and we've taken great care to provide a deep integration with the most popular cloud management systems on the market. So be it OpenStack, CloudStack, or OpenNebula, or ONAP, or even if you have your own custom in-house cloud management system, you can connect to your management system to the StorPool API and have direct control over the storage system directly from your cloud management system. So for example, this is OpenNebula here. And the way it works is that data stores in OpenNebula become what we call pools or templates in StorPool, and images in OpenNebula become volumes in StorPool. So every image you have in OpenNebula is not just a file on a shared file system with no control over it. Every volume, every image in OpenNebula becomes a separate volume in StorPool. So these images you see there, so image say 20 and 19 and 18, they are separate volumes in the storage system, which means that you can control them separately in terms of where data is placed for them. So in this case, some of the data is only on SSDs, other volumes are on SSDs and hard drives. And you can also control them separately, each virtual disk, each image separately, for how many IOPS or how many megabytes per second limit do you want to impose on them. It also gives you the ability to have snapshots that the storage system is aware of and produce cloned virtual machines without any storage space overhead, right? Our aim is to expose the full functionality of the storage system to the cloud management system. In some cases, it's the cloud management system that is limited in some way, meaning that it doesn't have some functions, and we can't make it understand features in StorPool that it doesn't natively understand, right? But we try to go to the largest extent possible with these integrations with OpenStack, CloudStack, OpenNebula, etc. Right. So what you have, another thing you have in this test cluster is there is this virtual machine running on StorPool, and one thing we wanted to show is that when you have a shared storage system, what you can do is you can live migrate this virtual machine from one node to another. And there are several, when you do that in the cloud management system, there are several events that happen in the background in the storage system. So I'm going to keep this window open here, and I'll explain what happens there. So when I move, it's currently running on host 2, and I'll move it to host 1. And I'll just start the live migration. So what happens is the cloud management system attaches the virtual disk to the destination host where the VM is migrating. And when the VM is finished migrating, so it's now running on host 1, when it's finished migrating, it detaches it from the previous volume. So the OpenNebula in this case orchestrates the steps necessary in the hypervisor as well as in the storage system to move the VM and its associated connection to the shared storage system from one host to a different host, right? And the other thing we wanted to show you was performance. And I'm not sure how many of you are familiar with FIO, but FIO is a popular tool for measuring performance of mostly of block storage systems. So I have this test volume here. So the system we're testing on has 12 SSDs and 12 hard drives in 3 servers. So it has 3 servers and their client or initiator nodes on the same 3 machines. We're running the test from one of these machines, right? So the test volume in question is this volume called test. It's a 50 gigabyte volume with 2 copies only on SSDs. So it only uses the 12 SSDs I mentioned just now, disk list. And the SSDs are, there's nothing special about the SSDs or the network. So the SSDs are Micron 9500 DC SSDs, which are 800 gigabyte each. When we perform read or write operations, they are spread evenly among all 12 SSDs in the storage system. So if we start with the write test, so this is sequential write with 1 megabyte block size and IO depth of 64, meaning 64 parallel operations. It can do something like 1.2 or 1.3 gigabytes per second. Another thing I forgot to mention is the test volume is already fully allocated, which means that if I perform any read operations now, they will come from the actual SSDs underneath and wouldn't be like made up zeros. Because in a thin provision system, if you do read operations, they would be it will make up zeros and give you zeros. And it's important when you test the system, more dynamic system like this, that you allocate the volumes first. And in this case, it's already allocated. So we saw 1.2 gigabytes per second for sequential write. And we'll get something like 3 gigabytes per second, and it's going to drop down to less than that for sequential read. Then for random writes, we're doing all these tests on the same volume. So for random writes, we get with a large IO depth, we get something like 100,000 IOPS. It's important to note that all of these tests I'm doing now are from a single initiator. It's not the full capability of this 3-node storage system, but it's what you can get from just one initiator. So this got something like, let's say, 100,000 IOPS, and then for random reads, it can get something like 200,000 IOPS. Again, 12 SSDs on a 3-node storage cluster with 2 times 10 gig connection to switches. There is nothing like extraordinary in the hardware underneath.
It's a rather small configuration.
Yeah, we would consider this a starting config. So there are some customers who start even smaller than this, but we think something like starting with, say, 6 or 12 SSDs is a good starting point for a distributed storage system built on StorPool. And the last tests I have are on latency. So we think latency is very much underestimated in its impact on applications. So we think actually latency is maybe the most important aspect of the performance of a storage system, because a lot of applications depend on low I/O depth latency. So for example, a database server would issue write operations one by one, and it would wait for each write operation to complete. What I'm showing here is latency under load. So we have random reads with block size of 4K and I/O depth 32. And I've limited it to 100,000, which is not the full capability of the storage system, but it's what you could consider, say, moderate load. So something like, we just say about half the capability of the storage system. And with that kind of test, you get the 100,000 IOPS that we're limited to, and you get 200 microseconds of average latency. There are some outliers in this test, so like the 99th percentile is about 99.9 percentile is about 1 millisecond, and the 95th percentile is about 300 microseconds, right? So there are some outliers, but the average rate of the storage system completing these IOs, including waiting in the queue because there are 32 operations in parallel, is 200 microseconds, right? And then I also have the same for the random writes, 4K 32 in parallel with a limit at about, say, half the full performance capability of the storage system. Now I'll leave that to run for 10 seconds or more. So that gives you an average latency of 400 microseconds of latency under load with queue depth of 32. So that includes waiting in the queue and a lot of other operations being completed at the same time. This gives you an average of 400 microseconds with 95th percentile 600 microseconds, 99th percentile 700 microseconds, right? So it's even under moderate load, we're doing way under a millisecond latency in this fairly small storage system, right? So in large storage systems, what you wouldn't get lower latency, right? So the latency depends on the individual drives in the system and the time it takes for us to transfer the data over the network and all that. In a larger system, you would get an increased throughput, meaning you can run thousands of virtual machines with similar parameters rather than just a single or say tens of virtual machines doing this. So in terms of demo, I think the very important aspect of these new modern, I should say, storage systems is how do they react, how do they work under, say, failure? What happens if we lose a storage node? So what I'll do is I'll start one of these performance tests, say the random write. And I'll just leave that running. And while that's running, I will shut down one of the storage nodes. So I'll run the performance test on node 1, and I will kill the StorPool server service on node 3, just to show what the impact of that would be. So we have random writes with a large I/O depth to the test volume. And I'll find the StorPool server service here. And I'll just kill it in the most harsh way possible, right? So what you saw there is IOPS dropped to say 50K IOPS, and then it came back to 100,000 IOPS. So what's happening at the moment is because this volume has 2 copies, and one of the servers is missing. So some operations are actually being confirmed with just a single copy in place. And then if we bring, so we were working with one server missing, and if we bring that server back up, so we have the disks, its disks are back in the cluster, and it's now recovering the changes. So it's now recovering changes only on the SSDs. So it has 4 SSDs and 4 hard drives. And we were writing to the SSDs, so it's now the writes that we were performing, they're now being resynced. And we only resync the differences, right? We don't, we don't need to resilver the whole SSD just because the server was out of the cluster for a few minutes, right?
But the important part is the volume and the VM that's using this
continues working. So if you have, with 3 copies, if you have 1 or 2 servers missing out of a larger cluster, the system will just continue to work without interruption. And then when these servers come back, they will resync only the differences. This also allows us to do things like rolling updates in service, rolling updates, where we bring down the servers one by one and do any changes you need to do on them, like say a kernel update or update of the StorPool software, etc. Then bring them back in the cluster and resync, right? Cool. Okay. So that concludes the demo part. And if you have any questions, just don't hesitate to ask.
You have a Q&A platform on the left of your screens. When you hover with the mouse on the left, it should appear a small menu and it says Q&A there, and you can pause them. And now we'll hand over to our colleagues from CloudSigma to share their experience with storage systems.
Hi, my name is Martin Vazev, and I'm Director of Support and DevOps at CloudSigma. In this session, I'll share our experience within the years with the distributed storage system that we have used. In the beginning, we have started with different distributed storage systems. All of them were using high SCSI connections, and which basically caused a lot of issues because periodically the sessions were breaking, which needs restarted and caused interruptions with the storage performance. The resolution time with the different providers was low, which caused additional downtime when we experienced issues, and we were limited to. We were lacking some very important operations like live migrations. We were limited to the RAID system, storage, and etc. Thus, we have decided to build our own distributed storage system. And when we started with this, we didn't know that this is a brand new industry, totally separate from the cloud infrastructure that we already offered. We spent a lot of efforts and time building our own distributed storage system. Unfortunately, we faced almost the same issues with the other partners that we used in the past. We were still experiencing the same issues with the iSCSI connections. We experienced issues with the drive size limitation. When I'm talking about drive size, it impacts both the max drive creatable. We have a strong limitation on this, and the number of drives that we can create on a single storage node. The performance as well was not the one that we expected, and we receive a lot of complaints from our customers as well. We spent like a lot of efforts. When I say a lot, it means like something like 90% from our dev team and the operations team at the same time, dealing with the storage system, which bring new issues to us, like we start lacking some functionalities and stuff. Instead of focusing on releasing new features or fixing some bugs within our infrastructure, we were firefighting with the storage system. Again, we couldn't make the live migration works, mainly only with one operating system we managed to do so, which was totally unacceptable because we are an infrastructure service provider. We offer all the different distributions to our customers. So this the live migration was total failure for us. We used the RAID 6 model, which hides a lot of risks, especially when the distributors of our equipment, sometimes when they're lacking of some resources like SSD drives or some other resources. It was a huge risk. Fortunately, we never get to the point of losing any of the data of the customers. We tried different distributed systems. When I said so, it means both SSD and HDD providers. All of them had a lot of limitations and issues. Last year, I believe before a year ago, something like that, we decided to stop spending so much efforts and money on the storage system that we have, because it turned out, as I said, it's a whole new industry, and we would like to focus on the infrastructure as a service and cloud as a service. So we met our new partners, StorPool, and we started building our relationships and platform together. Since we are with StorPool, I can say that most of our, it will be too big word to say all of our issues disappeared, but most of our issues disappeared, and we are not worrying about our storage system anymore. Why? Because first, the performance is expected even better. We're receiving a lot of positive feedbacks from our customers. We are not limited anymore with drive size. Currently, we have customers running about single drives with size about 30 terabytes, which is something huge. We are not limited to the RAID functionality anymore. And as per the demo, you saw that the hybrid solution gives currently we're using the 3 copies of data, and even we can lose an entire node from our storage system without experiencing any interruption or data loss. It gives us cost efficiency. Also, we managed to make it work, the live migration, with like 90% of the operating systems that we offer to our customers. And also our cooperation and work together make us to realize that the Intel hosts are much more reliable and give us also better performance. So we decided also to switch our host from AMD to Intel, and just now we have like high availability and great performance. The guys are really responsive. Here, my colleague Patrick can say more about the operations part of StorPool, but in general, we are now in a better situation, much more better situation, and I can say that we are building the future together.
Hi, I'm Patrick Bailey. I'm a co-founder at CloudSigma. So just carrying on from what Martin said, one of the primary motivations of working with StorPool we're looking for a vendor who can not only provide a storage solution, but also actively manage the storage solution. So with StorPool, they're completely responsible for the storage layer of our service and work in close cooperation with our operations team in case of any issue or outage. We have a very close development partnership, so we have a very clear roadmap of features and the way the product is being developed into the future. So we as a cloud provider are exposed to a large number of issues and customer requirements, and we closely liaise with StorPool to bring up those issues or those features which are very important for our client base. As an example, in the last 6 months, in terms of operational complexity, we have rolled out 4 new locations in 4 new countries in both Asia and Europe. And we have been able to do this seamlessly, doing our own deployment and the deployment of the StorPool storage facility in each location. We have fully tested, user tested, and now we have active customers in all these new locations. So it's expanding our availability on a geographical basis across the world. Lastly, I would say, as a cloud provider, we're constantly testing new technologies, new products. So we work closely also with StorPool, for example, testing new SSD drives, new SSD technologies. So the R&D stage of product development is very closely tied for both CloudSigma and StorPool. Lastly, on a personal level, we have always found the management at StorPool to be highly technical, competent, and very proactive to any suggestion problems that we have had over our relationship since we started. Thank you.
Martin, Patrick, thank you for sharing this insight. It's been a pleasure to work with you. And also, I think it's a very common, most of the problems you described, we see them over and over again in different companies from this domain. Everybody who's trying to build a public or even a private cloud struggles with more or less the same issues. Send us an email if you have any questions, and don't hesitate to contact us, or don't hesitate to ask questions that might be relevant to building your cloud, or to check out our documents. So that's always, our blog and CloudSigma's blog regularly post interesting and useful stuff that's not only StorPool related or CloudSigma related, but it's general stuff that can help you build a better service.